Let's solve the following problem, which asks us to show that the line that joins the origin, the point with coordinates 0, 0, 0, to the point with coordinates 1, 2, -1, and this other line that joins the point with coordinates 1, 1, 1 to the point with coordinates 0, 7, and -5, these lines intersect and find the cosine of the acute angle between them. Okay, so let's first of all give these lines names. So L1 should be the line joining 0, 0, 0 to 1, 2, and -1, and L2 should be the line that joins the point 1, 1, 1 to the point 3, 7, and -5. So each line is given by two points on it, so we can write the equation of these lines as we've learned in the lecture. So each point on this line on the first line is specified by taking the vector pointing from 0 from the origin to this point, which is just 1, 2, and -1, and multiplying it by some number. So that's simply s, 2s, and -s with some parameter, little s, that is a real number. What about the other line? For this one, we will need a point on the line 1, 1, 1 with coordinates 1, 1, 1, and the vector that points from the point 1, 1, 1 to the point 3, 7, and -5, and that vector for this line is the difference of these two vectors, that is 2, 6, and -6. Okay, so just take the difference, take this vector and subtract this vector from it, you get that vector v2. So this is 1 plus twice some parameter t because of the first coordinate, then 1 plus 6 times that parameter t plus 1, and the third coordinate is 1 minus 6 times that parameter t. Okay, so this is the equation for the points. This is the coordinates of the points on the second line. And in order for these lines to intersect, what we need in the for the intersection point point x, y, and z, the coordinates x, y, and z, these equations should hold that the first coordinates should match, should be equal, the second coordinates should be equal to each other on these lines, and the third coordinates should also be equal, because this way we ensure that indeed this point is on line L1 and also on line L2, so it's really an intersection point. So from the first equation, we have s already expressed by t, saying that it's 1 plus 2t. So if we use that in the second equation, use it in 2, let's go then 1, 2, and 3, use it in 2 to get twice 1 plus 2t equals 1 plus 6t. So from this we get 2 plus 4t equals 1 plus 6t. That means that 2t is equal to -1, equal to +1. So t is equal to a half. So t is 1/2. S is then 1 plus 2t, 1 plus twice a half, that's 2, 1 plus 1. So s is equal to 2t is equal to 1/2. So the intersection point has coordinates that can be obtained by plugging in 2 in the first equation. So that's 2 for s 4 and -2. So that's the intersection point of the two lines. So here is L1 and L2, and here we have the intersection point. Let's call this P. And now what we need is the cosine of the angle between these two lines, which can be obtained by using the scalar product for these two vectors that point along these lines. V1, well, V2 we've already calculated, that's 2, 6 and -6, and V1 we have also calculated, that's 1, 2 and -1, because we have to subtract zeros from each component. So V1 equals 1, 2 and -1, and V2 equals 2, 6 and -6. So we get the cosine of the angle between them if we take their scalar product and divide that by the product of their lengths. This is just rearranging the definition of the scalar product for these two vectors so that the cosine of the angle between them is expressed using the scalar product and their length. And if you calculate the scalar product, you will get 2 plus 12 plus 6. So 2 plus 12 plus 6 by multiplying each coordinate and then adding them up. And this is divided by, well, the length of V1 is the sum squared of its coordinates under the square root. So that's 1 squared plus 2 squared plus 1 squared. That's root 6. And the other vector has coordinates 2, 6 and -6. So 2 squared plus 6 squared plus -6 squared, that's 4 plus 36, that's 40, plus 36 again, that's 76. That's 76. So what we have for the cosine of this angle is 20 divided by the square root of 6 times the square root of 76. We can certainly simplify this by basically taking a square root of 2 from the square root of 6 and the square root of 2 from the square root of 76. So that would be giving us a factor of 2 in the denominator, by which we can simplify, and we are left with the square root of 3 and the square root of 38, which gives us 111 under the square root. So that's just multiplying those two numbers to get 10 over the square root of 114. This is a positive number, the cosine of theta, so this is indeed the cosine of the acute angle between them. So this is the solution of this problem.